Okay, number 21 from chapter 11. The simulation, okay, let's talk about it. It's about state lotteries and how do you increase your chances of winning their systems and so on. One system is called lucky numbers. You pick a number and you play it over and over again. Now maybe some numbers are luckier than others. That is, some numbers would come up more often than others. Let's use a simulation to see how well this system works. So we simulate a simple lottery in which a single digit from 0 to 9 is selected as a winning number. Pick a single value to bet, such as 1, and keep playing it over and over again. You want to run at least 100 trials. If you can program the simulations on a computer, run several hundred. So it's not hard, easy. It's not difficult to run using the sheet of random numbers. What proportion of the time do you expect to win? Well, it would seem mathematically you'd expect to win 1 out of every 10 times. Are there luckier numbers? Well, we can try that. We'll try 7 or whatever. So the simulation question is, what proportion of the time do you expect to win? One trial and the component are the same thing, one lottery. So one number. You pick a number and you either win or lose. The possible outcomes are 0 to 9. The response variable is whether or not you win the lottery. And then at the end, you're going to evaluate how many times you win. All right, now here's our numbers. As they suggest, let's go with the suggestion that 1 is a winning number and 1 is your number. So in the first 2 rows are 100 numbers, which represent 100 lotteries. So all we have to really do is just count the ones. Okay, so let me put on the inking tools. Okay, so here's a 1. Here's a 1. Okay, so we're saying 1 is a winning number and 1 is your number. So how many times is it going to come up? So the first 5 there's no 1, second 5 there's 1, third 5 none, fourth 5 none, fifth 5 there's 1, none, none. Here's 2, none. Here's 1. Okay, so out of the first 50 you won 4 times. So that would be, now you would have expected to win 5 times. So that's pretty close. Okay, the next 50. Here's 1, 0. Here's 1, 0, 2, 1, 0, 0, 0, 0. So let's see total. 2, 4, 5, 6, 7, 10. You won 10 out of 100 times. That's what you would expect mathematically, how many times to win. All right, now let's go with let's say 7 is a winning number. So now we're going to go with lucky numbers. So we'll do the next 100 lotteries are going to be the next 2 rows because there's 50 numbers in each row. Okay, so here's a 7. 1. No 7s. Another 7. 2 7s. A 7. No 7s. A 7. 1 7. A 7. Okay, now to the first 50 we got 1, 2, 4, 6, 7, 8. We got 8 out of 50. Now mathematically we only should have had 5, but you know, with random numbers they can be streaky. Okay, so here's a 7. 1, none, 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 1. Let's double check that. 1, none, 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 1. Another 1. And then the last 3 there's none. So let's count them all up. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. So that's almost exactly certainly mathematically exact. It certainly doesn't mean, you know, that there's one number is luckier than the others. If you kept doing this and you selected 1 and then 2 and then 3 and then 4, the more trials you do, the more they're going to come out to a uniform distribution of the numbers of 10% zeros, 10% ones, 10% twos, etc., through 10% nines. So, getting back to the question, let's go back to the question, make sure we fully answered it. Okay, what proportion of time do you expect to win? Around 10%. Would you expect better results if you picked a luckier number, such as 7? No. We tried it. 7 didn't do. 7 had one more than 10, or than 1, so no. All right. That's that.